formula of pH for all this. Okay. So first of all, if the salt comes from weak acid and a strong base, so you know that when acid and base react together, they form salt. But if your base is strong and acid is weak, then the salt formed is basic. Basic salt, the solution will be basic. Or since in base you have anionic part hydroxide ion, so we can call it anionic hydrolysis because base is strong. So here KH value will be equal to Kw upon Ka. What is this Kw? Kw is ionic product of water and K is acid dissociation constant. And if you are going to write the value of this hydrolysis constant H, it will be equal to under root of Kh, that is hydrolysis constant, divided by, this is your H, capital H. Wait a minute. Divided by C. C is the constant. And if you want to write the pH value, pH will be equal to 7 plus half into pK plus log C. I will give you a trick to remember this formula. And if you have a strong acid and weak base, then the solution will be acidic, and we can call it cationic hydrolysis. Cationic hydrolysis, since it is acidic in nature, H plus is there more. That's, and here hydrolysis constant KH will be equal to Kw upon Kb. Basically, whichever in this acid or base will be weak, that will that's a constant will come in denominator. Like you can see, acid is weak, so we are going to use acid dissociation constant in denominator. Base is weak, so Kb, base dissociation constant, and accordingly H will be equal to under root of Kh upon C. Again, C is the concentration of the salt, and pH here will be equal to 7 minus, since this is you can also call it, this is your basic solution, and this is your acidic solution. Or you can remember with the help of this, since a strong base is there, anionic, so you are going to add it, or since cationic, so you are going to, it's just opposite, you are going to subtract it, and the rest part will be as it is. We just need to write pKb plus log C. Whatever is the weak, that will come here, pKb. Here the acid was weak, so pK, and the last weak acid plus weak base. If you are going to use both of them weak, then KH, as I told you, whatever will be weak, that will come in denominator. And since both are weak, so we are going to write it like this. Degree of hydrolysis, we can write it like KH upon C. And then if you are going for pH, pH will be equal to 7 plus half into pK minus pK. So these are the some formulas for hydrolysis constant, which is very important. Please do that. Let me know when you are done with this. Very good. Now moving to the next part, that is solubility product, buffer solution. See, what is buffer solution? A solution which resists change in its pH when you are going to mix a dilute very small amount of either acid base or solvent. That solution is known as buffer solution. So basically it's very simple. If you are going to add a large amount of acid base or water in a solution, it will change its pH. But if you are going to use a small amount, and if the solution resists to change its pH, then that solution will be known as buffer solution. Then that solution will be known as buffer solution. And it is of two types. The one is acidic buffer and another is basic buffer. Acidic buffer and basic buffer. Now, how you are going to recognize whether which one is acidic and which one is basic? So it's very simple. A solution which contains weak acid with a salt, and that salt comes from a strong base and weak acid. So it's very simple. A solution which contains weak acid and the salt of that acid with a strong base. Let's take an example, CH3COOH, which is ethanoic acid, organic acid, which is weak acid. And the salt, take it as CH3COONA, and this salt comes from weak acid, that is ethanoic acid, and a base, that is NaOH, sodium hydroxide. Are you getting my point? So this mixture, basically, this mixture, you can see CH3COOH and CH3COONA is acidic buffer. Is that clear? So any solution which contains weak acid with a salt of a strong base, that is called acidic buffer. Are you getting my point?
Yes.
In the same way, if you are going for basic buffer, that means weak base plus salt, and this salt is made up of this weak base and a strong acid. Let's take an example, NH4OH, ammonium hydroxide, which is weak base, and a salt NH4Ca. Now this salt comes from a weak base that is NH4OH and a strong acid, that is HCl. So this is the scenario. You can see it's very simple to understand. Basic buffer is that which comes from or which are prepared by mixing weak base and the salt which comes from a strong acid. So these are basic buffer and this is acidic buffer. Now from here you can easily calculate the pH value of this buffer solution, whether it is acidic or basic. So for acidic buffer, pH will be equal to pKa plus log of whatever is the concentration of salt upon whatever is the concentration of. So this is basically your Henderson equation. This equation is known as Henderson equation, as it is given by Henderson to calculate the pH of buffer solution. This is your Henderson equation. Now, if we are going for this basic buffer, it's also very simple. POH is equal to PKB plus log of, again salt will be here, and since it is basic, so we are going to put the concentration of base in denominator like we did for acidic buffer. So this is how we will calculate the value of POH in basic buffer and pH in acidic buffer. If someone will ask you what will be the pH of the basic buffer, it's very simple. As I already told you, pH plus POH is equal to 14. And if anyone asks you anything, you can easily convert this with the help of this formula. Let me know when you are done with. So have you all revised amines chapter?
Yes.
Very good. So today I'm directly gonna give some questions on amines. Everyone done with this? Okay. Now moving to the next. That is your solubility. Now see, solubility is what? If you have salt, AgCl, you are going to first dissociate it into ions Ag plus Cl minus. And look if it is balanced or not. So this equation or reaction is already balanced. Let's say this has a solubility S. Since SV2, this will also have solubility S because both have stoichiometric coefficient is 1. Now we are going to write the solubility product constant expression of KSP. KSP stands for solubility product SP and K is constant. So solubility product constant. Solubility product constant is basically deals with product is equal to whatever is the concentration of the product, we are going to multiply it. And if the stoichiometric coefficient is 1, you are going to put the value 1. If it is 2, you are going to put the value 2. Now you can see what is the solubility S. If it is S, then you are going to write S, and here it's also S. So the value of KSP here will be S square, and the solubility will be under root KS. You will get it. I'm going to take an example, another example. If you have MgCl2 and someone asked you to what is the expression of KSP, so you are going to dissociate it. You know that magnesium will go in +2 and Cl will go in minus. Now in order to balance it, I'm going to multiply it by 2, and now the atoms and charge both are balanced. Now you can see this is your solubility S, then the solubility of this will be 2S. Since this is 2 mole, this is 1 mole. So now again KSP will be equal to the concentration of Mg plus 2 into concentration of Cl minus. That is basically solubility. Solubility of Mg plus 2, solubility of Cl minus raised to the power 2, because it's, you can see this is your 2 as a stoichiometric coefficient, and then S into 2S whole square. So here KSP will be equal to 2 to the 4 S cube. Is that clear, everyone?
Yes, sir.
And you can write SP will be equal to KSP upon 4. And again, S is equal to under root of KSP upon 4. Here it will be 3. Root cube. Not square root, square cubic root. Now I'm going to give some salt, and you are going to tell me what is the value of KSP. KSP. Let me know when you are done with this. Very good. Calculate the expression for KSP of formula. KLCl3 Al2 SO4 all twice. Then I'm going to get CuCl. Please do this. Alia, are you able to solve it? Somewhere. Very good. We know, are you able to solve it? Alia, Hannah, Anna. Please do let me know if you are not able to solve it. Very good, Samira. Please do the last one. Yeah, very good. Anna, are you there? Alia, Stania, and Avino. No one is responding at all. See, if you are going to dissociate this, this will give you. Okay. This will be dissociated into L plus 3 and Cl will be dissociated into minus 1. Okay. No problem. So in order to balance it, you are going to write 3 here. And it will be 3s and here it will be s. Now for KSP, it will be equal to s into 3s raised to the power 3. So it will be 27 s raised to the power 4. Now if you are going to dissociate this, it will be L plus 3. And since 2 aluminum is there, we are going to write 2. And this will be 3SO4 minus 2. Now if you want to write the KSP, you know that SP will L plus 3 will have 2s and this will have 3s. So 2s is the solubility, and what is the stoichiometric coefficient 2? So it will come into the power. 3s is the solubility of SO4 minus 2 and power is 3. So it will be 108. If you are going to multiply it, cube it and square it and then multiply it, it will be like this. And this is just similar, same as MgCl2. It is just like that. So this will be your copper will go in Cu plus 2 and 2 Cl minus. This will have 2s and this will have s. Now for KSP, you know that this is the first solubility of this, and it has its stoichiometric coefficient 1, so the power is 1, and this has a solubility 2s. So KSP here will be 4SQ. Is that clear, everyone? Please do respond so that I'll move to the next.
Yes, sir.
Okay. Thank you. Now just let me know the answer. Question number, are you able to see the new screen, Samara?
Yes.
Please do question number 36. Just let me know if you are unable to do it. Abhinav, I'll just check it. Very good, Abhinav. First of all, we need to calculate pH and NaOH is given, from which we will get concentration of NaOH. So I'm going to calculate the value of pOH. pOH will be equal to minus log of OH minus. And you know that if you are going to dissociate this, it will give Na plus and OH minus and OH minus. 1 mole of NaOH will give 1 mole of OH minus. That means basically if 0.01 m is there of NaOH, then the concentration of OH minus is also 0.01 m. That means 10 raised to the power minus 2. So here I'm going to take 10 raised to the power minus 2, and this 2 will come here, and it becomes 2 log 10. And this will have a value of pOH, that is 2. But we need to calculate pH. So as I already told you, that pH plus pOH, that means 2 will be equal to 14. So pH will be equal to 12. 14 minus 2, that is 12. So the answer is D. Very good, Avino. And Samira, have you got it?
Yes, sir.
Alia, why are you not responding? Are you not able to solve the question? And Anna, Sania. Okay, moving to the next question. Can anyone tell me conjugate acid of NH2 minus? Okay, Alia. So conjugate acid of NH2 minus. Very good. To make a conjugate acid, what you need to do, add H plus and you will be getting NH2. See, to get conjugate acid, you need to add H plus. And to get conjugate base, you need to remove H plus. So the answer will be B. Just wait a minute. What I needed to. Yeah, question number 96, question number 89, and question number 97. Please do this. It's wrong answer, Samara. See, this is your strong base, which is wrong. In buffer solution, if it is acidic buffer, then you have weak acid plus salt with a strong base, plus salt with a strong weak acid and a strong base. This is the formula. And if you are going for basic buffer, then weak base plus salt, and this salt comes from weak base and a strong acid. So whenever in a solution, if you have a strong acid or a strong base, that will not be buffer. In this, a strong acid is here. In this, a strong acid is here. It is also not. If you are going to look at this is your nitrous acid, which is weak acid, and NaNO2. This is your salt come from NaOH, which is a strong base, and NO2 is a weak acid. So this is a salt. So the answer is D. Very good, Avino. '96. No, 96 not A, B. Please check your calculation. Yeah, it is A. Samira, what about 96? Samira,
So can you solve?
okay, M2S is here. I'm gonna share the screen. Another screen. You can see. M2S. Sulfur, S, that is sulfide. So it will be it will be 2m plus s minus 2. Now the solubility of m plus will be 2s and solubility of s minus 2 will be s. If you are going to write the value of KSP, it will be 2s raised to the power 2 and s will be like this. Now you can see you are going to solve it like this, and solubility is given as 3.5 into 10 raised to the power minus 6. 3.5 into 10 raised to the power minus 6, which raised to the power 3. And after solving it, you will be getting 1.7 into 10 raised to the power minus 16. This will be the answer for 96. Is that clear, Samira?
Yes, sir.
Okay, can I change the slide?
Yes, sir.
Now question number 97. And for 97, what is 4 into 10 raised to? No, it's a wrong answer. Avino, please do check it. We need to calculate the solubility, that means S. The KSP is given. We now see what you need to do. If you are going to dissociate this B8, it will be B plus 2 and 2A minus. Whatever is here that comes in positive, and whatever is here that comes in negative, you can do in this way, and solubility S will of this and 2S is this. So here you can see KSP will be again equal to 4S cube, in which KSP is given as 4 into 10 raised to the power minus 12, and here 4 and S cube we need to calculate. You can see you can easily cancel this, and here S cube will be equal to 10 raised to the power minus 12, and S will be equal to under root of 10 raised to the power minus 12, and here it will be 3. And you can also write 10 raised to the power minus 12 raised to the power 1 by 3, and here you can see it will get. So the answer will be B. We now got it. Samira, Hiran.
Yes, sir.
Now see, we are going here. This chapter is completed. Now we are going to do the amines chapter. So I think you have revised all the chapters as I told you in the previous class. If you have any doubt in any concept, you can tell me. Am I audible? Okay, Samara, are you able to see on your screen?
Yes, sir.
Okay, so you are going for question number 1. Alia, any answer? Carbolamine test. What is the answer? Very good, Anna. And Samira, it's wrong, not C. C is your 2-degree amine. Carbolamine test will be given by 1-degree amine. So this will be your answer. Carbolamine test, primary. You are going to write. Here you can see this is your 2-degree, this is your 3-degree, this is your 2-degree, and this is your 1-degree. Is that clear, Samara?
Yeah.
Okay. Now question number 2, read question number 2. The amine that reacts with Hinberg's reagent to give an alkali insoluble product. If you remember, Hinsberg reagent is basically benzyl sulfonyl chloride, C6H5, SO2Cl, benzyl sulfonyl chloride, and this will be given by, this reaction will be given by 1-degree amine as well as 2-degree amine. And in 1-degree amine, we get soluble alkali. We get soluble alkali, and in 2-degree amine, we get insoluble alkali. So if you are going for this is your 1-degree, so it will be soluble. If you are going for this, you can see this is your 2-degree, so it will be insoluble. Wait a minute. 1-degree is soluble. This is your 3-degree that does not react with Hinsberg. This is your 1-degree, it will give you soluble. But option B, you can see this is your 2-degree, so it will give you insoluble. Are you getting my point? So you have to know the work of the reagents. Is that clear, Anna, Hannah, Hiram, Samira?
Yes, sir.
Okay. Moving to the next question, which is very good, Hannah and Anna. Question number 3. Very important questions. Very important question. The basic strength. If I'm gonna ask you some question, just wait a minute. Let me take this to OneNote, and I need to explain some concept about this, which is very important. Are you able to see a new screen?
Yes, sir.
Okay. Here, see, the basic strength in this chapter is very important. First of all, I'm going to ask you some question, then we will move to this question number 3. My question is very simple. Ammonia that has a formula NH3, which has a lone pair, you know that, and there is aniline, or you can call it benzenamine, which also has lone pair. Both are 1-degree. Now, I want you to ask which one will be most basic. Most basic. What do you think? Most basic, ammonia or aniline?
Ammonia.
Why ammonia is more basic? So as we know that basic strength directly proportional to plus I and directly proportional to plus. Okay. So as you can see, this lone pair is free and it can be donated to anyone. But this lone pair is constant, that is busy in resonance. So it cannot be easily donated. And the one which donates easily, the electron pair, will be more basic. That's why ammonia will be always more basic than this amine. Okay. Now, The most important point is that when we are going to deal with the basic strength of amine, we are going to deal in two phases. First, gas phase, gaseous state or gaseous phase. So in gaseous phase, we are going to deal with 3-degree amine will be more basic than 2-degree amine than 1-degree amine. Why it is so? So you know that 3-degree amine is surrounded by 3 alkali group, and 2-degree amine is surrounded by 2 alkali group. This is your hydrogen, and 1-degree amine is surrounded by only 1 alkali group, and alkali group has plus I effect. So this 3-degree is supported by 3 alkyl group, and this 2-degree is supported by 2 alkyl group, and this is one alkyl group. So this will be the more basic in gaseous phase, and then this. The lowest basic will be this. Okay. And if you are going to talk about solution phase or in aqueous solution, so basically this trend will not be followed because of 3 reasons. The first is solvation. The second is you can go for steric hindrance, and the third one is your inductive effect. So according to or on the basis of these 3 factors, we saw practically that if you have R as methyl, R as CH3, that means methyl, then 2-degree, that means 2-degree, you can see this is your CH3, H, and this is your CH3. Most basic, then comes your 1-degree, then comes your 3-degree, then comes your 3-degree. This is the basic question. And if your R is alkyl group, C2H5, sorry, alkyl not ethyl group, R is alkyl ethyl group, then again 2-degree will be the most basic, and then comes your 3-degree, C2H5 whole thrice I'm gonna write instead of 3 times, 3-degree, and then comes your, at the end, it comes the 1-degree. So in alkyl group, in ethyl group 2-degree, in methyl group 2-degree. But in methyl group second position 1-degree, and this is your 3-degree, and this is your 1-degree, and this is your wait a minute, 1-degree, 3. Okay. Now this is your 3-degree, and this is your 1-degree. And after this comes your ammonia. So this is very important, and now you can easily decide, since methyl is the alkyl group, so in methyl secondary is the most basic, and then primary, and then tertiary. So the answer is that clear?
Yes, sir.
Very good. That means you have revised this chapter. Now I'm gonna give you another question, which is very easy. Can you change the slide?
Yes, sir.
Here comes your next question. Please do this first. Question number 5. See, very good, Samara. Any answer from any one of you? Samara is given the right answer. Alia, Anna, Hiran. See, it's very simple. So to basic strength direction directly proportional to plus I and plus N. Now you can see there is no plus I and plus N in this benzene ring. There is minus I, and this is your plus I, and this is also minus N. And as I told you, basic character inversely proportional to minus I and inversely proportional to minus. You can see this due to plus I effect, it will be more basic. So third will be the most basic. And then you are going for this, then it will be wrong. It decreases the basic character, basic strength due because it is connected with minus I electron withdrawing group. So this will be the second step, and this. Is that clear, everyone? Samara, go for this. Everyone go for 13, question number 13. Which of the following compound is most basic? No, it's a wrong answer. See, this is directly connected to benzene ring, and there is minus N group also. If you are going for this is your lone pair, and again CO, that means C double bond O is there, which will withdraw this electron towards itself. So this lone pair is basically busy in resonance. This also busy in resonance, but this is not in conjugation with the resonance. It can donate, and it will be the most basic. Samara, this will be the most basic because it can donate its electron. Its lone pair is not in conjugation, so it can easily donate. But all of others lone pair are in resonance or are in conjugation. That's why they will show resonating structure. Okay, Samira.
Yes, sir.
Okay. I'm not going to give the option for this question. Please do it. And if you are not able to do it, just let me know. I'm going to explain. See, this is your ketone, and if you are going to react this with first step CS3NH2, so see what will happen. It's very simple. This H2, I'm going to write this as H2NCH2. So basically, there will be removal of this water molecule. This is your NH2. Wait a minute. I'm gonna show. This is your double bond, and I'm gonna show this H2N CH2. So what you need to do, just remove this H2, and you will be getting double bond N CH, double bond N CH. And after this, if you are going to react this with LiAlH4 followed by hydrolysis, you know what will happen? This will reduce. That means this bond will be broken. Hydrogen will be added here. Hydrogen will be added here. So the final product that you will get, this will be NHCH3, and this will be acid. So please do write it and let me know. Are you done with this?
Yes, sir.
Okay, very good. Again, I'm going to give you a question on acid basic strength. Please do it correctly. I think you can do this. It's very easy. Oh, very good. No one is responding at all. Very good, Samara. So it's ethyl, and as you know that in ethyl 2 degrees more basic than tertiary, and then comes your after tertiary, then comes your second. Sorry, wait a minute. First secondary, and then comes your tertiary, and then comes your primary. So this is your, you can see this is your 2 degree, this is your 3 degree, this is your 1 degree, and this is your ammonia. So the answer will be B. It's very simple. Go for the next question. Yes. Just wait a minute. It wasn't working. Any answer for the 45? Nitrobenzene on reaction with concentrated HNO3. If you know the reagent, this reagent, which is very important reagent, then what will happen? Wrong answer. See, nitrobenzene, that means this is your nitrobenzene. Just wait a minute, Samara. So this is your nitrobenzene on which you are going to react this with HNO3 in the presence of H2SO4. And as I told you, with this reagent, when they react, they generate an electrophile, that is nitronium ion, NO2 plus. Now, this is your electrophile, and where it will attack, that depends upon the group that is attached with benzene ring. And since this NO2 is minus M group, so this will, the minus M group is meta directing, so it will directly attack on the meta position, and you will be getting 1,3 dinitrobenzene. It will be A. Is that clear? Samaira, Iram,
Yes, sir.
Hannah? Okay. Go for question number 43. Which of the following will be the most stable diazonium salt? Very good. See, this will not be stable. This will not also be stable. This will also not be stable. But this will be the most stable because this benzene to which this N triple bond NX negative is connected, that will be basically in a resonance with this. That's why B will be the most stable. This is not in conjugation. There is no resonance. There is no resonance. There is also no resonance. And we know that in stability, we give preference first to the resonance, then hyperconjugation, and then comes your inductive effect. Go for question number 44. Which reagent you are going to use? Very good, Samara. So in this, generally we use H3PO2 plus H2. By reaction of this, we get this oxidizes into H3PO3 along with HCl and N. So the answer is PO. Next question is this. Which is formed when acetonitrile is hydrolyzed. When acetonitrile is hydrolyzed partially. See, acetonitrile is methyl cyanide. Methyl cyanide. And this methyl cyanide is partially hydrolyzed partially with cold concentrated HCl. So it's very simple. You can see methyl nitrite, cyanide, CH3C triple bond. And if you are going to react this with concentrated HCl, so this will be directly converted into amide. This will be directly converted into amide. Is that clear? Basically, there will be there will be, since we have H2O, that means H plus and OH minus, and you know that this will have negative and this will have positive. So this will go with this and this will go with this. So we will get first CH3COH and then double bond NH. Again, water will attack and there will be again H plus with this and OH minus with this. So what we will get, CH3, C NH2, I'm gonna write it here, and OH here and OH here. Two hydroxyl group on a single carbon is less stable. So you are going to remove water from here and then you will be able to get this. So what will be your answer? Your answer will be acetamide. So it's very simple. Please go for question number 36. Tomorrow, any answer for question number 36? Compound A reduce, then we get B, and gonna react this with HNO2, nitrous acid, then you are getting alcohol. If you are not able to solve it, just let me know. This option cannot be correct because here you have two carbon and here it is three carbon, so maybe it is not correct. There is only one carbon, this will also not be there. There is two carbon, CH3NC and CH3C. So I'm gonna take this. If you are going to CH3, use CH3CN and reduce it, what you will get? CH3CN, if you are going to reduce it, you will be getting CH3CH2 NH2. Cyanide reduced to this, what we say, amine. And after this, you are going to react this with HNO. HNO can be written as HONO. Okay, and then you will be getting CH3CH2OH. So the right answer is D. Please do it. And then go for question number 30. Very good. Samara, the answer is correct. Now go for this reaction. 33. I'm going to explain this 35. 35 is an isocyanide is prepared by working no, Friedel craft no, words no, it is by carbolamine reaction. Whenever you are going to do the carbolamine reaction, you'll be getting isocyanide. Now go for question number 3. 33, you are going to tell me what is the product. Let me know if you're done with this and if you are unable to solve. Okay, I'm going to explain. First of all, if you're going to react this with Grignard reagent, so what will happen? If you are going to react this with Grignard reagent, you know that nitrogen is more electronegative, so it will take electron from carbon and there will be positive. And again, you know that this will have positive and this will have, sorry, carbon is non-metal, so it will have negative charge and this will have positive charge. Again, I wrote positive, sorry. Carbon is non-metal, so it will have negative, this will have positive. So this negative will be attacking here and this positive will be attacking here. So what you will get C double bond N and then MgBr and this CH3 attacked on that position and the rest part is as it is. The rest part is as it is OCH3 at metabolism. After this, if you are going to do the hydrolysis, you know that this will be directly converted into imine like this. You can see this is your CH3 and then this is your C. It will be double bond NH. Basically, you have H plus and OH minus, and you know that this nitrogen has negative and this has positive. So this will go with this and it will form this, and OH will go with this MgOH. After this, since it is present in acidic water, again this will attack and this will be removed and you will get C double bond O. COCH3 we can directly write as well. So this will be written as COCH3 and here it is OCH3 which is. So this reaction is quite important. Please do revise. You have your test on Friday in which I had given. Just wait a minute. I'm going to check the syllabus. I had given equilibrium